Last time we talked about our new form of a linear equation called the point-slope form. So we're going to continue that discussion today and go through some problems and take some notes related to it. So on this page we have a number of situations, and we have to figure out which form of a linear equation would be used. So first off, let's write at the top of the page what the forms are again. So we have the intercept form that we are most familiar with, and that's our y equals mx plus b, where m and b stand for the slope and the y-intercept values. And then we have our point-slope form that we learned last class. So point-slope form. And this form uses a point, but instead of using the y-intercept point, it uses a point anywhere on the line, but we also need our slope. So when we plug this in, we get y minus y sub 1 equals m times x minus x sub 1, where m is still the slope, so m is the slope, but x1 and y sub 1 are a point on the line, okay? So any point on the line rather than just the y-intercept point. All right, so let's take a look at example 1. So we're told that we have a y-intercept of 5 and a slope of -2. So which form do you think we would use? Would we use the point-slope form or the intercept form? Hopefully you're remembering that if we have a y-intercept value and we have a slope value, that means that we're using the intercept form. So we will write down the intercept form. And we will write the equation for the intercept form. So y equals mx plus b. Y equals m is the slope, so our slope is -2. So -2x. And our y-intercept is 5. Remember, b stands for the y-intercept, so plus 5. So y equals -2x plus 5. Problem number 2. We're looking for the equation of the line through the point -1, 4, and a slope of 3. All right, so this time we're given a point, and we're given a slope. So if we're given a point and a slope instead of a y-intercept and a slope, that means we're going to use the point-slope form. So remember, in the point-slope form, we're given the x and y value for a point, and we're given the slope. So we're going to first off write the point-slope form. And we're going to then write the equation. So y minus y1 is how we start the equation. So y sub 1. So the y value is 4. So y minus 4 equals m times x minus x1. So remember, the slope is the m, so slope is 3. Parentheses x minus the x1 point, so the x value of our point. So x minus -1. All right, now remember from last class we talked about if we have a minus a negative. When we have subtracting a negative, remember that's really the same thing as adding. So we're going to change that to a plus. And we also talked about last class, the point that you see, -1, 4, when you look at it how it appears in the equations, it'll actually kind of be the opposite of what it looks like because the original equation already has the subtraction sign. So if you add another negative in there, it changes to a plus. So you'll see this is looks like a +1 here where the x value of the point was -1, and you'll see a -4 here where the y value is +4. That will always be true when you plug these in. It'll look like the opposite. All right, number 3. Lifetime Fitness advertises a sale where new members pay a joining fee of only $19.99 and then a monthly fee of $35. So now we have to kind of think about what each form is giving us and how it fits into this context. So if we're looking at the joining fee of $19.99, hopefully you're seeing that's kind of like a starting value, a starting amount, and how the $35 fee is a monthly fee. So you're going to be paying it each month. So we pay each month. So we have a starting amount, and then we have amount that it's going up by each month. Your total amount of cost is increasing by $35 each month. So if we think back to which form that would be, if you have a starting value, remember that's kind of like the y-intercept. The y-intercept is kind of like the starting amount. And we talk about a rate per month. Like this is a rate we're paying per month. That's kind of like the slope. So we have a slope in either case, but in this case, since we also have a starting amount, then the intercept form is what's going to work best. Okay, so y equals mx plus b. In this case, we have a monthly fee is kind of like our slope, our rate of change each month. So 35x, and then we have our starting amount, which is like the y-intercept, which is $19.99. So that would be the equation. In number 4, okay, now we have a graph. Notice that we have 2 points that are identified on the graph. There's many points on the graph, but we have 2 points that are identified on the line. And then we have really this line that continues up. Now, if we were using the intercept form, we would need to figure out what the y-intercept would be. But you can see on this graph, it's kind of hard to see where the graph is going to eventually cross the y-axis. So in this particular case, we know we have at least 1 point. We have 2 points actually right here, and we could maybe even see some more. And since we have 2 points, we can figure out a slope. We can figure out a rise over run value. So we notice that this goes from 9 down to 5 here. So if we count each one of these as 1 unit, so we're going down 4, and then we're going to the right positive 3. So as a rise over run, we have -4/3. So we know we have the slope of -4/3, but do we have a y-intercept to use? Not really. And we can't really see what the y-intercept is. We could maybe try to trace our way back to it. So we don't really have the y-intercept value, but we do have a point. Actually, we have 2 points, right? We've got this point right here, which would be 2, 9, and we have this point here, which would be 5, 5. So 5 on the x and 5 on the y. Okay, so we can use either of those points, but again, since we have points and we have a slope, we're going to be using the point-slope form. And when we have more than 1 point, we can use either point. So let's plug that in. So we got y minus y1 equals m times x minus x1. So let's do y minus, let's take this point right here. So the y value for that point is 9. So y minus 9 is equal to our slope, which is -4/3, times x minus the x value for our point, which is 2. Okay, if you did the other point right here, you could have written that equation as y minus the y value for our point, which would be 5, equals our slope, -4/3, times x minus the x value, which is also 5 here. So either one of these equations would work, and they would be equivalent to each other. If we simplified these, we would come up with the same intercept form equation, and so they both are the equation of the line. So either one of those would work. Number 5, the Hawkins Spirit Shop starts tracking their inventory of medium sweatpants when they receive a delivery. 3 weeks later, they have 20 pairs left. On the 5th week, they have 10 pairs left. All right, so this one, again, we kind of have to think about what we're given here. Are we given a starting amount? 3 weeks later, 5 weeks later, we're not really given the starting amount here. What we're given is that we have 3 weeks and 20 pairs, and we have, at the 5th week, we have 10 pairs left. So we're sort of indirectly given 2 points, where the x value is the weeks, so the weeks is the x value, and the y value is the pairs left. So we're given 2 points, and so we can't really use the intercept form then. We must still have to use the point-slope form. However, this time we're not really given the slope directly, so we have to use our little slope formula. If you remember, to calculate a slope given 2 points, we subtract the y values to get the rise, and we subtract the x values to get the run. Well, in this particular case, to get the y values here, we'll have to subtract, well, it depends on which one you want to do first. If you want to do, let's take the second one minus the first one here. So I guess this would be the second one. So the second y value would be 10, and the first y value would be 20. Okay, so 10 minus 20. And then our slope for the run, the x values, will be the second x value minus the first x value. So our slope ends up being 10 minus 20, which is negative 10, and 5 minus 3, which is positive 2. If we simplify that, that would simplify to negative 5 over 1, or just negative 5s. So our slope on this problem is negative 5, and our point could be either one of these points. So again, we're going to use the point slope form, and we're going to take one of those points, so y minus y1. Let's just take this top point here. So y minus the y value for the point, 20 is the y value for the point, equals our slope times x minus the x value for our point. So our slope is negative 5, x minus the x value, so x value for a point is 3. Okay. Real quickly, if we use the other point, we used 5, 10, we can do y minus the y value equals our slope times x minus the x value of our point. So either one of these equations would work for the point slope form for this particular problem. Again, if we simplified these equations, we would actually end up with the same thing. They look different now, but we would end up with the same thing. Both of them would have a slope of negative 5, and we would get a y-intercept value after we simplify them as well. All right, last problem here, we have a graph. And this time you'll notice that although we have 2 points on the graph, and we could actually do the point slope form, one of the points is the y-intercept. So that's the y-intercept right there. The y-intercept is 3, or 0, 3 if you want to be picky about it. And we can also then use our graph to figure out the slope. So if we look at the rise over run here, we've got a run of 1, we've got a rise of 2. So slope is going to be rise over 1, which is 2. So I guess if it were me, I would probably choose the intercept form here, because we do have a y-intercept, and we do have a slope, and so that I guess would be easier, although you could also use the point slope form if you prefer. So y equals mx plus b is our intercept form, m being the slope, so 2 times x, because 2 is our slope, plus b being our y-intercept. In this case, it is 3. So y equals 2x plus 3 would be the equation of the line in intercept form.